All right, YouTube, Reddit, whoever's out there, thanks for watching this video. Today we're going to transmit an image by using amplitude modulation. See the link below this video. I got all the MATLAB scripts for the creation of the image processing. So please download it, use it, steal it, and best of all, experiment and learn something. All right, here's a quick review of what is the transmit_pic MATLAB file going to do. It's going to prompt you to let you open a JPEG file. We do a little chirp math and we'll save it as a WAV file. This is the WAV file now that you want to send to your AM transmitter so that we actually transmit a picture through the radio waves using amplitude modulation. So what the file is doing is we're reading in the image file, converting it to a black and white file, so it's strictly just intensity only. Color has been removed. We're converting it to a one-dimensional vector. We are then convolving that vector with a chirp waveform. Oh my goodness. And we're using the IFFT and FFT to do that convolution. If you don't know what convolution is, Google's your friend. And then we save off a WAV file, and this is the WAV file that you now will be feeding essentially the audio signal to any AM transmitter. All right, so you can, once you got your WAV file, you can send it to any transmitter, a SIGGEN, HackRF, or maybe you got some old tube monster. You can send the audio to that, and you'll now transmit an image using amplitude modulation. All right, the receive file, basically the idea is the opposite. We are first receiving the signal using some SDR receiver, RTL dongle, whatever you want. That goes into SDR software. You're setting that software to AM mode, and you're telling the software to record the audio and set the audio sample rate to 48 kilohertz. So essentially we're going to record the audio and then process it in MATLAB. So here we have the WAV file that you recorded from your SDR software. We process it in MATLAB, we do chirp compression, and we reshape the vector back into the image, and hopefully you'll see your image. So this project uses many things. One of the most important is the match filter, chirp signals, and AM modulation. If you don't know what any of these things are, I would recommend Googling them. So why did I use chirp signals? Well, it's very common either in sonar or any kind of imaging application to use a chirp. And why is that? It's because when you run a chirp through a match filter, you get a very nice spike, which is perfect for imaging and making closely resolved images. The match filter, again, in this program, we're using the IFFT and FFT to do that. And again, a match filter is something that's going to detect a very particular waveform, in our case, a chirp waveform. So you can use an FIR filter or convolution with an impulse response equal to h of n equals to the conjugate of whatever the transmit signal is flipped in time. That's what that n-1 means, is I'm flipping the vector backwards. That's it. That's a definition of a matched filter. It's used extensively in radar, sonar, digital communications. Anything with a known signal is going to have a matched filter on the receiver side to essentially pull that out of the noise and get the best SNR possible. All right, now we're going to demo it, the receive process, for you guys to see how to do it. And again, see the link below the video. All the MATLAB and WAV files are there, so you guys can experiment and have some fun. Thanks for watching. All right, folks, before we show the SDR software, we'll quickly go over some tips and tricks for running the MATLAB scripts. And, all this is going to use MATLAB. If anyone out there wants to convert these to Python, that would be very nice. That way, no one needs MATLAB, but I'll leave that for someone else out there if they want to do it. All right, so the first thing we got to do is run the pictx script. Again, this will read in the JPEG, convert it to a WAV file. So simply open it up in the editor and click run, and they'll see a bunch of prompts to let you run it through. All right, so when that script runs, it's going to dump out this H and W numbers here. These are very important. These are the height and width of whatever image you loaded. So you're going to need to put these numbers into the receive script. So write these down because you're going to need to edit them or put them in the receive script. That way I know what was the dimensions of the picture. And here's a picture of the actual final WAV file that you would send to your transmitter. Or you could just send it as a baseband through a telephone line or something. You don't really need a transmitter, but I figured this can either be a wireless or wired experiment. But here's the chirp. This is the preamble. That's what allows me to know when the signal is starting. And then all this blob here is the image converted to a one-dimensional vector, and then we've convolved the chirp with the opposite slope across all those pixels, and that's what you're seeing here. So on receive, I first find this chirp that tells me the start of the file, and then run a match filter against all this data to compress and get that final image. Okay, so you've recorded your WAV file from your SDR program. Now you need to run this pic_rx file. Again, this will process the WAV file and create the image. But before you run the script, you need to enter in down here whatever was the pixels of your picture. All right. Once you got them entered in, simply click run, and it will ask you where's your WAV file, and then it will display the image. Now, if you have an image and it looks, the image is shifted, I have this variable down here. You can either make that a positive or negative number to shift the image. I think that's mainly due to the clock drift on the SDR receiver. But anyway, this is what this command down here does. So simply change that from 0 to whatever amount of pixels you think it's shifted by. Just enter that number in there, rerun the script, and your picture should now not be shifted. All right, let's start recording, folks. Start recording. Start. All right, we're recording the audio of the AM signal. Here starts the video, or the image, I should say. It takes about 30 seconds for it to transmit the image. Again, this is amplitude modulation, and we are recording the audio of the AM signal. All right, and once you see that, that's the end of the chirp. We can stop the recording.